basically, what we now know is that for each ball, we'll start with the first one. We have the force diagram here, the force of tension of the string. We have the electric force from M2 to M1, and then we have the force of gravity, which is mg. And then we can split Ft into two components here. Ft in the x direction and Ft in the y direction. So the balls are separated by the charge that they both have. One is Q and the other one is also Q. 2Q?
Yeah, I'm trying to do it.
And under masses,
I don't know why
right now, for part A, the masses M1 equals what, M2, which equals M. So our purpose here is to determine the ratio between the two theta values, which are these. And so right now, since neither of the balls are moving, we can basically assume that the forces here are balanced. That means Ft of x equals Fg and F of E equals Ft of y. So to start, you can say that Fe equals Ft of y, which equals cosine? Cosine. Theta. So this is going to be for ball 1. Yeah, for ball 1. Fe equals Ft of y, which equals cosine. Okay, no, it's fine. F1. And then we can also say that mg equals Ft of x, so from this equation, we can get that Ft equals Fe over cosine theta 1. So we can now plug the Ft value into this equation here. So we can get that mg equals oh, I'm doing it the wrong way. Shoot. From this equation, we can get that Ft
create it easily at your
For your own safety. Bless you. I think.
Okay, so Ft from this equation equals 1 over cosine theta mg. And if we plug it into the equation from above, we can get that Fe equals sine theta times 1 over cosine theta mg. And then from here, we can get that Fe equals tan theta, still theta 1, Fg, and tan theta 1 equals Fe over Mg. And I'm just using M, but M1 equals M, so the mass of 1 equals M. And then this whole process can be repeated for ball 2. Basically, we have FE FTY, which equals sine theta of 2 FT, and then we have the second equation mg equals FTX, which equals cosine theta 2 FT. And the only difference, as you can see, between ball 1 and ball 2 in this particular equation is that one is theta 1 and one is theta 2. The actual equations are both the same. So if we apply the same process from ball 1 onto ball 2, we can basically deduce that tan theta 2 also equals FE over mg. And since the FE values between the balls are the same, you can say that FE, we can make these two equations the same. So basically, if you combine the equations by substituting the FEs, you can get the equation that tan theta 1 equals tan theta 2. And so therefore the ratio between the tangents is 1 to 1. Because tan theta 1 over tan theta 2 equals 1. So 1 to 1 ratio, so that is 1 over 1, which is okay.
Yeah.
Okay, so for part B, the setup is exactly the same, except the only difference is that for ball 1, well, ball 1 is the same exact thing because the mass is the same, but for ball 2, the mass is twice the mass of ball 1. So if you do the same exact process, you end up with the equation of tan for ball 1, that tan theta 1 is equal to F over mg, and for ball 2, tan theta 2 is equal to Fe over 2 mg. And if you solve like you did in the problem before, you have tan of theta 1 over tan of theta 2 is equal to theta 1 over theta 2, which is equal to Fe over Fe over FE over FE. And the FE's cancel out, go to FE. So you get the ratio of wait, okay, wait.
Dude, that is 1. That is 2.
Yeah, no, but it's 1 over.
It's 1 over 1/2.
It's 1 over 1/2, which is 2.
Oh, it's 1. Oh, yeah, okay. It's 1 over 1/2, which equals 2.
Okay. Oh dear. Okay, you can stop for now.
You still have to do C. Come on, yeah.
We're done.